So today we're going to do the third problem from the 2017 AP test. It's another classic problem where the question gives you essentially the derivative, the graph of the derivative of a function, and where you are tested on your knowledge of continuity, differentiability, relationship between a function, its first derivative, its second derivative, what it means to be continuous, differentiable, concave, all of this. So they have a lot of concepts involved in this type of questions. Okay. If you feel good about those, then go right ahead. Sorry. And if you don't feel comfortable with those kind of questions, my advice will be to take a breather, look at the picture, and say, try to identify things right away. Like, for example, I'm looking at this picture, and right away I'm seeing that at this point, the function, the graph right here, is continuous but not differentiable. Same thing right here, it's not differentiable. Why? Because I have a sharp point. I see that the slope from the left appears to be vertical, and the slope for the right is positive. Okay, so it's not the same. The slope right here at x equals 3 appears to be positive right here and negative right here. So I know the function is not differentiable. Now, I don't see a gap right here, so it is continuous. But anyway, try to look at the problem so that you don't dive in right away and step back a bit. Now, what else do I see? I see that often in those problems, there is going to be some kind of area under the curve that happens. So because I'm nervous right now, it's an AP test, right? So I'm going to just do something. Now, I realize you might not have the time to do a lot of things like that, but when you review, when you practice, to build your confidence, do that. I see, for example, that the area right here that I have under the curve for this triangle is something that is fairly simple to calculate, right? The base is 4, the height is 2, so the area right here will be 4. And if I do the same thing right here, I see that the base is 3, the height is 2, therefore the area is 3. Then right here, I see a half circle. The radius of this half circle is 2, so pi r squared is 4 pi divided by 2. This area right here will be 2 pi. And even if I don't use it later, it just took me, 20 seconds, and I'm building my confidence. Hey, I did something. Okay, so what else is given to us? So the function f is differentiable. It satisfies f of negative 2 equals 7. The graph of f prime is given, 3 line segments and a semicircle. Okay, so the important thing that we need to realize right here is f at negative 2 is equal to 7. That means we know one place where the function is defined completely. Okay? First question, what is f at negative 6 and what is f at 5? All right. Well, since the graph that is provided is the graph of f prime, I know because of the fundamental theorem of calculus that the integral of f prime x dx between a and b will be equal to f of b minus f of a. We know that. Which allows me to write the following integral. The integral from negative 6 to negative 2 of f of prime of x dx. Why that one specifically? Let me show you. Well, I'm going to try to find f of negative 6, so I'm going to put a negative 6. Why negative 2 then? Well, because we are provided with the value of the function at negative 2. So by doing it like this, this allows me to write that this will be equal to f at negative 2 minus f at negative 6, which means that since I'm looking for f at negative 6, it's going to be equal to f at negative 2 minus the integral from negative 6 to negative 2 of f prime of x dx. Now, I hope that you've seen these kind of things before and that you remember this technique from before. However, if you haven't, please do practice it because it's very common. It's extremely common that you have to use this approach to finding values. Okay? So now we look at what is provided. F at -2 is equal to 7. The area under the curve between -6 and -2, which is essentially what this means. This means the area under the curve between -6 and -2. This area under the curve, if you look at the graph, is just a 4. And so we have 7 minus 4 equal 3. F at -6 equal 3. Okay. Now, I've seen samples of student work on the AP test that are really that like presentation, that likes neatness and explanation. Remember that the people who are going to grade your test, they're going to have 100 papers to grade. And if you're lucky enough to be among the first, then they're going to have energy, they're going to be forgiving. If it's not neat, they're still going to look for it. But if you're among the last ones, they're going to so appreciate a neat, beautifully explained paper. So try to box your answer, try to show your work, for your own sake. All right, so we're going to do the same thing for F5. So it's going to be F at -2 minus the integral between 5 and -2 of f prime of x dx. Now, you might complain right here, say, wait a second here, we have a 5, we have a -2. Don't we have the smaller number right here? Yeah, we can think of it that way, but it really doesn't matter that much because we can change it into this here. Okay? Which means that we're going to have, instead of f of -2, 7 plus, and what is the area under the curve between -2 and 5? Well, between -2 and 5, we're going to have all of this, which is -2 pi, and this, so 3 minus 2 pi. So plus 3 minus 2 pi. Therefore, f at 5 is going to be 10 minus 2 pi. And we have this beautiful result right here. Okay, we're done with part A. Let's look at part B. Okay, 10 minus 2 pi. Part B. On what interval is f increasing? Justify your answer. Okay, so whenever you have questions like this, my advice would be to first state the rule. So you would say that f is increasing when f prime of x is greater than 0. That's simple. That's the rule right here. F prime being the slope of f. If f prime is greater than 0, it's positive, then the function is increasing. Okay? Therefore, and we're going to look at a picture, f prime would be positive when the graph is above the x-axis, so between -6 and -2, and then between 2 and 5. Okay? Therefore, for all values of x that belongs to the interval, and what did we say? -6, -2, union 2, +3, f prime of x is greater than 0, therefore f is increasing. Okay? Now, the question is, when is f increasing? So when the derivative is greater than 0, right? Therefore, f is increasing on, and be careful right here. Here, we are going to have closed interval. All right. So now we are done with this. Let me just highlight this answer right here. I don't want to box something like this, it's too big. And that's simple. Let's just move on to part C. All right, let's read it. Find the absolute minimum value on the closed interval -6, 5. Okay, so find the absolute minimum. We want the absolute minimum. Absolute minimum on the interval -6, what was it again? 5. -6, 5. Wait a second. Above, that's, yeah, above. That was not 2 and 3, it was 2 and 5. My apologies for this. This is supposed to be a 5, not a 3. All right. There you go. Fixed. So let's talk about absolute minimum or absolute maximum. Okay, they happen either when the first derivative is equal to 0 or at the boundaries. So the critical point, I shouldn't say just the first derivative equals 0. The critical point or the boundaries. So what are our candidates for the absolute minimum? Okay, so we're going to have the boundaries. So the absolute minimum is going to happen at -6, at 5. And guess what? That was the first question. We already did that. This one was 3. This one was 10 minus 2 pi. Okay. But we're also going to check the critical points for it. So what are the critical points? Well, the critical points, we need to look at the graph. And so for what values are, for what values is f prime equal to 0? So f prime is going to be equal to 0 right here. It's going to be equal to 0 right here. And the graph doesn't have a derivative right here, and right here. Okay. So let's see what we can do with all of this. So we're going to have for candidate the boundaries here, -6, +5, and -2 and +2. All right, so we have f of -6, then we're going to have f at -2 and f at +2. So we can use the same technique that we use for part A for all of this. Okay. So f of -2, what will it be? F of -2 will be, oh, wait a second, f of -2 is already given to us. It's 7. Okay. And what is f at 2? Well, f at 2 is equal to f at -2 plus the integral from -2 to 2 of f prime of x dx. This area under the curve is the area of the semicircle. So we know that this one is going to be 7 plus -2 pi. So this is going to be 7 minus 2 pi. Now, since we are looking for the absolute minimum, the question really is, among those 4 values, this one, this one, this one, and this one, which among those 4 values is the smallest? Okay. So between those two, that's going to be 3. Between this one and this one, well, we can say that pi is about 3.2 to make sure that we're good, right? So that will be 10 minus 2 times 3.2. So that's going to be 6.4 So 10 minus 6.4, 3.6. So this is still smaller. And 7, yeah, that's going to be the smallest. Okay. So we can say that f at 2, which is equal to 7 minus 2 pi, is the absolute minimum value on the interval -6, 5. Okay. Well, we're making good progress. We're almost done with this one. Okay, let's look at D now. All right, so for each of f double prime at -5 and f double prime at 3, find the value or explain why it doesn't exist. So we want f double prime at 5, and we want f double prime at 3. All right, let's look at a picture. At 5, we have this, and at 3, we have this. Okay. Oh, not at 5, -5, my apologies. -5, so -2, 3, 4, -5 right here. Okay, sorry. Let me go fix it down here. It's going to be at -5. Okay. Well, f at -5 is going to be graphically represented by the slope of the graph of the function f prime at -5. Are we okay with that? So let's look at it. At -5, what is the slope right here, right? So it's going to be -2/4 over that segment, so it's going to be -1/2. Okay, so this is going to be -1/2, and we're good, right? Same thing for f double prime at 3. It's going to be represented graphically by the slope of the function f prime at 3. So let's go and look at the picture. At 3, what do we have at 3 right here? At 3, we are over here. So there's a problem right here, because if we take the slope from the left, right, it's going to be this right here, which is m equal 2. And if we take the slope from the right, it's going to be this one right here, which is m equal -1. And so if the slope from the right and the slope from the left are not equal, that means the function does not have a defined derivative at that point. That means that f double prime does not exist. Okay, it does not exist. And to justify this on paper, you would say that the limit as x approaches 3 from the left of f double prime of x is not equal to the limit as x approaches 3 from the right of f double prime of x. You could say something maybe like 2 is not equal to -1. Okay, and hopefully this will be good enough to give you full credit on this kind of problem. So the answer to this one is -1/2, and the answer to this one is the slope doesn't exist. Okay. Sorry for the little mistake earlier, but be critical toward your work, and you will find them. Okay, all right, take care.